All right. Final one or two pieces of the puzzle to fit into place here. This one, fairly simple. You've been doing it already. Now it just looks a little more difficult, but doesn't have to be. This is lesson 92, simplifying complex fractions. You will recall that from 6th grade, a complex fraction is a fraction in a fraction. And we have an algorithm, a way of dealing with that called outer, upper, inner, under. All right, this works exactly the same in algebra. You'll be a class genius when you try to explain outer, upper, inner, under to your high school classmates who have never heard of that before. And you see that you simply take whatever's on top and bottom, the outermost factors, they get multiplied together to make the numerator. The innermost factors, B and C in this case, get multiplied together to make the denominator, and then you make sure it's in simplest terms. So, you'll see things that look intimidating, like this, A over X over B over A plus X. Remember that in complex fractions, there's always one fraction bar that's longer than the other two, all right? That's your dividing line. That's the top and the bottom, all right? Sometimes you'll see a fraction and then just one thing on the bottom. But that longer line than the top fraction is your clue how to approach this stuff, all right? So very simply, I mean, we take outer A times this, and recall that it's A times all of this. Therefore, when we write the answer, we got to put it in parentheses. So we got A times the bottom there, A plus X, and then inner X times B, XB. We look for shortcuts. No, there aren't any shortcuts. That's it. That's the answer. All right. Yes, you could distribute that if you wished, but probably not worth it. All right. And we can make things look a little more complicated and add your old friend, the GCF. Right? Here, if we go outer, upper, we simply take 3x times everything x plus 2. And inner, under, we got 9 times everything 6x plus 12. However, I mean, this should be a tip-off right here that the 3 and the 9 can be canceled out. And you'd be right. I mean, this 3 goes away and that 9 becomes a 3. But notice that there's a GCF inside the parentheses. Don't forget to factor that out. So I got the 3, that's this 3 right here. And I look at the GCF, which is another 3, right? Because I can factor out a 3 from both 6 and 12. So that's times 3, parentheses, 2x plus 4. Oh, wait a minute. 3 isn't the biggest, isn't GCF. It's just a CF. Let's go back and recognize that what we're talking about is the biggest thing I can get out of 6 and 12 is 6. So I factor out a 6, and I get x plus 2. All right. 3 times 6, 18, x plus 2. But wait a minute, I got an x plus 2 on top, and now I've got an x plus 2 on the bottom. I can cancel those out. I just got an x on top and an 18 on the bottom, and so there's my answer. X over 18. Everybody see that? And I suppose I could have waited to cancel out here until I multiplied 9 times 6, but then I'd be dividing that by 3 and getting 18 anyway. All right? One little wrinkle on this, all right, is when you've got a subtraction problem of a rational expression in either the numerator or the denominator, all right? Here I got 1 over x, no problem, over, and now I got 1 minus 1 over x. Well, here we have to use our old friend, the common denominator, and we see that the common denominator here is x. I used to have a 1, but now I'm putting it over x, so what's changed? There's an x down there, so I have to put an x on top, 1 times x. And you'll notice that I've just changed 1 into x over x, which is 1 anyway. But now that I have a common denominator, I can rewrite this tricky little thing as x minus 1 over x, right? Top minus the top over the common denominator. Now I go back and look at my fraction, and I've got a complex fraction. A fraction, large fraction bar, and another fraction that I got from changing this into that. And now, outer, upper, 1 times x, inner, under, x times x minus 1. The x's cancel out. Now, yeah, the x goes away, but that doesn't mean there's nothing on top. All right? x over x is 1 over 1. So there's a 1 here on top. All right, if you don't write the 1, you get it wrong. Be careful. So simplify, this becomes 1 over x minus 1, and you're all set. Try something like that again. This is as hard as it gets. I got this 1 minus 1 over x plus 1. Well, I need a common denominator here. That would be x plus 1. So I get x plus 1 over 1 minus 1 over x plus 1. But I ask what's changed. Well, now I've got a new x plus 1 over here, so I have to have x plus 1 here, which is x plus 1 over x plus 1, which is back to the 1 that I had before. All right, so you see what I did here. I just wrote a common denominator here. Now I can rewrite the fraction as x minus 1 minus 1 over x plus 1. But of course, x minus 1 minus 1, in simpler terms, is x minus 2 over x plus 1. All right? So this whole thing became that. All right? Pause it, follow it, write it down. All right? Don't skip steps. So now this is x minus 2 over x plus 1 over x over 2x. And yes, we could cancel that out and make that 1/2 if you wish. All right, 6 of one, half a dozen of the other, because now outer upper says I've got 2x, x minus 2 over x, x plus 1. All right, and so now I'll cancel out the x's here, and yeah, basically that's all I've got, right? So I've got 2x minus 2 over x plus 1. And again, please, there's no canceling out there. All right? So the only trick is when you've got a 1, you write a name for 1 using the common denominator. All right, that's it for lesson 92. Please do A to E and 5 through 7. Thanks.